Hello, welcome back. So now we're on to the maturity structure of interest rates. And we're going to start off with the yield curve. It's also known as the maturity structure or the term structure. And this shows the relationship between the yields to maturities on the vertical axis there and the times to maturity on the horizontal axis down there. And this is now on different bonds that have got the same currency, credit risk, liquidity, tax status, and periodicities. Remember periodicity? This is the number of coupons per annum that the bond pays. So in other words, what we need is we need the issue to be the same so that everything here is the same, but then we need to look then at bonds that have got different maturities. So here we got a nice example of South African government bonds. So this is obviously bonds issued by the government when they need to borrow money. And this is what the yield curve looked like on 16 July 2020. And this is actually when I made the slide. I'm only recording it in December 2020, but it hasn't really changed that much, which we'll talk about in a minute. But let's see what we've got here on 16 July 2020. We can see that this yield curve is what they call upward sloping, because the bonds with the longer maturities, like let's take this one, the 20-year maturity over there, it's paying a yield to maturity of nearly 12%. And then the bonds, the short-term bonds, let's take this one here, like the 2-year one, it's only paying just over 4%. So why is this? This is because the longer the term of the bond is, the more uncertainty there is. The more uncertainty there is, the more risk there is. And this means that the borrower, the South African government in this case, they then must compensate investors and pay them higher yields over here for the higher risk. And you might remember the very first slide that we did in this valuation reading, when we introduced yield to maturity, excuse me, another term for yield to maturity is the required yield. So investors require a much higher yield here for the longer term bonds because there's more risk compared to down here. So if there's such a short term to maturity, there's much less risk. So the required yield is going to be much lower. So this is what we normally see, upward sloping yield curve. But I just wanted to add that from time to time, we've seen yield curves that are actually downward sloping. So it looks something like this. We've seen this in America before, where the yield curve can look like this. And that doesn't happen often, but it can be that the longer the term of the bond is, the lower yield it has. And the shorter term bonds have got high yields. The higher yields, they call that an inverted yield curve, which we're going to talk more about at level 2. We're not going to really worry about it for now, but I just wanted to add that it can happen like this. But a few things we can just add in here for fun is that the benchmark bond that we normally use is the 10-year bond, the one you're going to see quoted in the media most often, the benchmark. So we can see that in July 2020, the required yield, the yield that investors demanded to invest in this 10-year bond was, let's call it, was just over 9%. Let's call it 9.5 or whatever. And I'm recording this now in December 2020. And I just checked what the 10-year yield is in December 2020, and it's 8.8%. So it's somewhere over here, which means that the yield has come down from July to December 2020. The yield on the 10-year bond has come down. So why is that? Because there's now, from investors' point of view, less risk than before, because if the yields goes down, then the required yield investors demand is going to be lower. So in other words, if the yield comes down, the bond is strengthening. So remember our relationship that we did in so much detail before in that Riverside retail example, yield down, price up. So the bonds have strengthened from July to December 2020. So what you could maybe do for fun is whenever you are watching this class, have a look at this website down here and see what the yield curve looks like when you watch this. So if it's, say, for example, over here, if it's lower, this means yields down, which means that the bonds have strengthened because the required returns that investors demand are now lower. But if the yields have gone up, this means that the investors perceive more risk in the bonds. They require higher yields, which means that the bond prices would have weakened, right? Because there's now more risk than before if the yields go up. So that's just some nice revision for us, yield down, price up, as we know, yield up, price down. So then another thing I wanted to mention regarding this 10-year benchmark, what we often do is we compare one 10-year bond to another. So for example, the US 10-year government bond, believe it or not, at the moment in December 2020, it's round about the 1% mark. So it's way down here. That's because, for as far as investors see it, the required yield is so low on the US government bond because there's such low risk that investors see in investing in a US government bond. In other words, getting their money back in 10 years' time. But they perceive the risk to be so low, so that the required yield is also going to be very low. So the difference between the South African government bond, let's call it 9% to make it easy, and the 1% in America, that difference of 8%, we call the yield spread, which we're going to actually talk about in the next online class. And then the last thing I wanted to mention, also just for fun, is that before COVID, the yield curve actually looked something like that. And this is after COVID hit. So this is like, let's say, January or February 2020. And why is this? Because after COVID hit, what the Central Bank of South Africa, they're called the Reserve Bank, what they tried to do was stimulate the economy by cutting rates. And when they cut rates, that affects the short end of the yield curve much, much more here. They call this a short end compared to the long end. So that's why this area is so steep, because short-term rates have gone so low. Anyway, we're also going to talk about that at some other time. That was just for a little bit of fun at the end there. So let's then carry on with, the important stuff we need to know for the exam. The next thing we need to know is the par yield curve. And this shows the relationship between yields to maturities, again, and times to maturity for bonds that are priced at par, of course. So the par curve is derived from a spot curve, which we're going to talk about in just a minute over here. So what we need to do is we need to solve for payment in this equation. So because we're trying to find the relationship between yields to maturity and times to maturity for the bonds that are par, we're going to put the bond there at par. And then the Zs, these are the spot rates on the government bonds. And these are always available. So these are the zero coupon bond rates. They are the spot rates. So this is the 1 year zero coupon bond rate, which it's available. We can find it. The 2 year zero coupon bond rate, etc. All of them we can find. So what I'm going to do, I'm going to tick what we can find. So that's supposed to be a tick. Let me try and make a better tick. There's a better tick. Okay. So that information we got, we can find these zero coupon bond rates or spot rates, no problem. So this now means that we can now solve for payment. But here comes the best news of all. There's no calculations needed. We just need to understand that's what we need to do. So once we've solved for payment, what is it? We know what this payment is, hey? It is, of course, it's the par bond coupon rate. Of course, that's the coupon rate. We know that. But they're also now saying it's the yield to maturity. That's what we're trying to do. We're trying to find the yield to maturity for different times to maturity. So why is it also the yield to maturity? Because remember this also goes way back. Remember when a bond is at par, like it is now, then the coupon rate and the yield to maturity, they are the same. So if we can find the coupon rate, then we've got the yield to maturity. So let's take this little example. Let's say we do it for a 3-year bond. We only go up to 3 years. So we're going to put in the 3-year zero coupon bond rate there. And there for 3 periods. We're going to have nothing in between here because we're stopping there end of year 3. So all the other information we got. And let's say this payment, let's say we've got the 3-year maturity and the payment comes out at 2.5. So that's going to represent the coupon rate. The coupon rate is then going to be 2.5%. And as we've said, if the bond's at par, that's also going to be its yield to maturity. So now if we want to do our yield curve, it's so easy because remember we've got yields over here, like from the previous slide, we've got time over there. So we said this was for a 3-year bond. So there we go. We got the 3-year bond. We've worked out the yield is over here. I'm just going to put it there. That's 2.5% over there. So that would be our dot over there. The 3-year bond has a yield of 2.5%. Then, of course, we would have to do it for each and every year, for 4 years and 5 years and 2 years and etc. Right? So it would be quite a mission. But fortunately, we don't have to actually calculate. We just got to understand what it is. Thank goodness for that. Right. So let's then continue. Now we're on to forward rate. So what is a forward rate? This is the rate that a borrower will pay and an investor will receive at a specified future date. So the forward yield curve now, this is now a series of forward rates where each forward rate has the same time frame. So in other words, the forward yield curve, it's composed of forward rates of the same tenor or the same time or the same maturity, but at different future periods. So this example will help because it's actually quite tricky the first time we see it. So here we've got a 1-year forward rate, 1, 2, and 3 years from now. So here's the 1-year rate 1 year from now. And so there's the 1-year rate 2 years from now, and there's the 1-year rate 3 years from now. So you see all of these at the same tenor. They're all 1-year rates, but at different future periods. So it's much easier to then look at the diagram to understand. So why would a company want a rate like this? Why, for example, would they want this rate, the 1-year rate 2 years from now? Well, maybe they're only going to be borrowing money in 2 years' time for 1 year. And they want to fix the rate today for the future because they're worried interest rates are going to go up. So they can lock in this forward rate today. Right. So that's all it is. So let's try another example, and that'll help us again to reinforce this. So now we've got a 2-year forward rate, 1, 2, and 3 years from now. So you can see here is a 2-year rate 1 year from now. And here's a 2-year rate 2 years from now. And here's a 2-year rate 3 years from now. So you see, I cheated here. I copied and pasted what was on the previous slide just to reinforce it. So the forward yield curve, it's composed of forward rates of the same tenor because each forward rate here has got 2 years. It's a 2-year rate each time, but at different future periods because this is in 1 year's time, that's in 2 years' time, and that's in 3 years' time. So for example, down the bottom here, a company might go for this rate if they want to borrow only want to borrow money 3 years from now for 2 years, then they can lock in this rate today. So that's all it is. Good. So now these forward rates, we need to go into a bit more detail. And this slide is all about the notation. So what we always need to think in our head here when we see these forward rates is we must say the second number first. So 2y1y means a 1-year rate 2 years from now. And 1y, 2y, so say the second number first. This is now going to be a 2-year rate 1 year from now. Okay, and then 3y, 2y, this is going to be a 2-year rate 3 years from now. And then the last one is SN, which is a spot rate. This is now an N-year spot rate. So let's say we've got, for example, S3, that's going to be the 3-year spot rate, which is going to be the rate today per annum for 3 years. So let's say, for example, the 3-year spot rate, I'm going to make it, let's call it 5%. So what does this mean? This means it's the rate today, we're going to get 5% per annum for 3 years. So if the 3-year spot rate is 5%, we're going to get 5% per annum for 3 years. Okay, dokes. So now what we need to do is get a bit more serious over here, and we need to calculate spot rates from forward rates. And just a word of warning, people don't normally like this at first, but actually it's not so bad. We're going to see it's not as bad as it really looks. So let's see what we've got here. The cost of borrowing for 3 years at the 3-year spot rate, that should equal the cost of borrowing. So this is over here, the cost of borrowing for 3 years at the 3-year spot rate. That's the top line over here. That's that, well, that the top arrow, I beg your pardon, over there. That should equal the cost of borrowing for 1 year at the 1-year spot rate, which is over here. And for 1 year at the 1-year rate 1 year from now, which is over there. And lastly, and then also 1 year at the 1-year rate 2 years from now. So that should be the case, right? So if we now put it into an equation form, the cost of borrowing for 3 years at the 3-year spot rate is going to be 1 plus the 3-year spot rate 3 times. And strictly speaking, this is what we call the compound rate that the borrower is going to pay. But strictly speaking, we're going to see this when we get to portfolio management. We actually subtract 1. That's a -1. It didn't come out too well, but that's supposed to be -1. But we also have a -1 on this side. We also have a -1 on that side. So they cancel each other out, so we don't have to worry about them. So what we can say then, the cost of borrowing here for 3 years at the 3-year spot rate, it should be equal the cost of borrowing for 1 year at the 1-year spot rate there, and for 1 year at the 1-year rate 1 year from now, and for 1 year at the 1-year rate 2 years from now. So when we set these things up, what I always like to do is make sure if I've got 3 periods on that side of the equal sign, then I need 3 periods here. So that's why I put everything to the power of 1. Didn't have to, because everything to the power of 1, it's just itself. And just before we go on to the next line, when we get to portfolio management, we're going to see that if you want to work out your compound rate that you're going to pay on average, or the total rate you're going to pay, or the total return the investor is going to receive, you take 1 plus each year's return, and you multiply them all together, and you subtract 1, and that's going to give you the total return the investor is going to make. So that's the total return over 3 years there, and that's the total return over 3 years there. So the two should equal each other. Otherwise, there's what we call the arbitrage opportunities. So now, if we want to, the bottom line is here, what are we trying to do? We're trying to calculate the spot rate from the forward rate. So now we need to solve for S3. So what do we need to do? All we need to do is bring that 1 across and make it a -1 there, and put everything here to the power of 1 over 3 to get rid of that power of 3 there. So that's all it is. And believe it or not, to cut a long story short, what the spot rate is, what is this? From quants, we're back to our quants again, reinforcing our quants. Isn't this wonderful? This is the geometric mean of these forward rates. That's all it is. So if we're given the forward rates, we can then work out the spot rate, no problem. So they've given us these rates here, the spot rate, and these are the 2 forward rates. So for the 3-period spot rate, all we do is we take 1 plus the 1-year spot rate there, and we take 1 plus the 1-year rate 1 year from now, and then multiply by 1 plus the 1-year rate 2 years from now, and multiply them all together, put them to the power of 1 over 3, take off 1. There we go. We've worked out the spot rate from the forward rates. Good news, we don't have to, if it's on the exam, we can just do the approximation, because the approximation just uses the arithmetic mean of the forward rate. So just rather take the arithmetic mean. It's going to be so close, we can't tell the difference. But from a theoretical, if they ask us a theoretical question, what is the spot rate? Theoretically speaking, it's the geometric mean. Okie dokes. So there we have it. Looks bad at first, but it gets better, right? Let's try another one. Now what we're going to do is we're going to go the other way. Now we're going to calculate the forward rates from spot rates. So similar to the previous slide, the cost of borrowing for 3 years at the 3-year spot rate over here, 3 years at the 3-year spot rate over here, that should equal the cost of borrowing for 2 years at the 2-year spot rate here, and for 1 year at the 1-year rate 2 years from now, right? So in other words, 1 plus S3 to the power of 3 times over here, that should equal 2 years at the 2-year spot rate here, and for 1 year at the 1-year rate 2 years from now. All right, so again, before we go any further, I always like to make sure before we start, have we got everything right? We've got 3 periods on the left, 3 on the right. So now we're good to go. So if we're given these two spot rates here, we can work out this forward rate, which is the 1 year rate 2 years from now, this guy over there. We can work that out over there. So here they've given us the spot rates. So they're asking us to calculate that in red there, the 1 year rate 2 years from now, the 1 year rate 2 years from now. So what we're going to do is rearrange this formula. So we're just going to divide both sides by 1 plus s to the power of 2. So this can be on its own. So I guess we could call that x, say, if we wanted to. We can think of it like solving for x now. It's just algebra. So all we got to do now is bring this 1 across and make it a -1, and then we can solve for x. So what do we need? We need the 3-year spot rate in the numerator to the power of 3, and we need the 2-year spot rate there in the denominator to the power of 2. And the 1-year spot rate we didn't need. Okay, they gave it to us to try and confuse us, to hope we would plug it in somewhere, but we're not going to fall for that. And there we can work out that is our that is going to be the 1 year rate 2 years from now over there. But here comes more good news. There's a lot of good news here in this class. We don't actually have to do that horrible algebra. What I was doing on the previous slide was working out on a compound basis. This is working out on a compounding basis. There, -1 and -1, remember, on both sides. We don't have to do that. The approximation works on a simple basis, so no compounding now. So now we know that told us the 3-year spot rate is 4%. What does that mean? We earn 4% per annum over 3 years over here, which is 12% over the 3-year period. And S2 was, the 2-year spot rate was 3%. So we're getting 3% per annum there over 2 years. That's 6%. So what does that mean? This means we must earn over here 6% over here. We need to earn 6% over here over 1 year, 2 years from now, to keep the equation in balance. And there we go. So the previous slide, I think it was 6.01. So this is now so close that we can't tell the difference. What was it? The 6.03, I beg your pardon. Now we're 6. So it's going to be always the exact answer. The exact answer will always be slightly more than the simple, because the simple is we're not compounding. With compounding, it will be a little bit more, 6.03. So I'm sure if it's on the exam, one answer choice might be 6.03, another one might be 7.03, another one might be 5.03. So we only have to do this, I'm sure. And then we're going to be just fine. So anyway, let's try then another example. So similar to 2 slides ago, the cost of borrowing for 3 years at the 3-year spot rate, this is over here, the S3 here, that should equal the cost of borrowing for 1 year at the 1 year spot rate over here, and for 2 years at the 2 year rate 1 year from now. For 2 years at the 2 year rate 1 year from now. That's what it should be. So if we set this up again, we've got 3 periods on the left of the equal sign. We've got 1 period there and 2 periods there. We're good to go. So if they want us now to work out the 2 year rate 1 year from now, we've set up what we need to do. So here are the spot rates again, the same as we had on the previous slide. So now to work out the 2 year rate 1 year from now, all we got to do is divide both sides by 1 plus S1 like we do there. So this can now be on its own. Again, we can call that X if we want to, I suppose. We've got to now solve for X. Now, this becomes a little bit more challenging than the previous example. So if your math is a little bit rusty, if school was some time ago, it might be a bit challenging. So maybe just ask somebody to help you, or you can ask me, let me know, and I'll help you. But let's try it anyway. So what is the 3 year spot rate? 4% there. The 1 year rate there, 2%, we put down there. And now what we need to do is, okay, so that divided by that comes out at 1.1028. So what do we need to do now? That is squared. So we've got to get rid of that squared. So we've got to multiply each side to the power of 1/2. So we've got to put that also now to a power of 1/2, because if we put both sides to the power of 1/2, that too is going to cancel with that 2, and we're left with what's down here. That now is to the power of a half, and that is now on its own. So once that's on its own, all we've got to do is take the 1 across there. That becomes a -1. And then we see that the rate works out at 5.01%. So this is now the 2-year rate 1 year from now. The 2-year rate 1 year from now. So this just then requires a little bit of practice, and we're going to be just fine. Okie dokes. So here's the good news slide again. Thank goodness for good news. Again, the approximation that works on a simple basis, no compounding. So S3 is 4%. So we're getting 4% per annum over 3 years over here. So that's going to be 12%. And S1 is the 1 year spot rate is 2%. So we're getting 2% over 1 year over there. So this means we need to earn 10% here over 2 years, 1 year from now, to keep the equation in balance. So there we got 10%. So we can then also check it here, that we take the 12% there, we subtract the 2% there, it's 10%. But this is now over 2 years. This is now over 2 years. So we're going to divide by 2 and get 5%. Why do we divide by 2? Because for the approximation, to get the 2-year rate 1 year from now as an annual rate, of course, we got to divide by 2. So again, this 5%, the approximation, that's very easy to work out. It's almost exactly the same. So if it's on the exam, we can do the approximation and we're going to be just fine. Okie dokes. So I know especially if you haven't read ahead or come across this before, I'm sure you're finding this a bit tough, but just go through the examples and the slides again, and I'm sure it's going to be all okay. If not, let me know. So we've got one more thing to do before we finish this online class, and that's now valuing a bond using forward rates. So do we remember way back when we valued a bond using spot rates? So let's just go back there and find it quickly. It won't take long. Where did we do this now? Wow, this was a long time ago. We've done well. Hey, we've done a lot since we've covered those spot rates. Where are you? There we go. So here, remember, we were pricing the bonds with the spot rates, where we had a different rate was used to discount each and every cash flow. So that's what we did way back when, just to refresh our memories. So now we've got something very interesting that we're going to come across. Let's just go back to where we were. Here, there we go. No, here we are. There we are. Okay, so there is we've been through that. So now, as we now know, we can calculate spot rates from forward rates like we did a few minutes ago. We can value the bond using forward rates, because the 2-year spot rate, or if we want to be exact, 1 plus S2 to the power of 2, which is a denominator over there, that's going to be the same as getting the 1-year spot rate for 1 year, and then the 1-year rate 1 year from now as well. So all we then have done is we have substituted the second term, the denominator has now become that instead of 1 plus S2. That's all it is. And then the same principle over here. So for the 3-year spot rate, 1 plus S3 to the power of 3. This is the example we did when we worked out the spot rates from the forward rates. You might remember the 1 plus S3 squared. That was the same as getting the 1-year spot rate, and then the 1-year rate 1 year from now, and then the 1-year rate 2 years from now. So all we've done again is we have substituted this 1 plus S3 to the power of 3 term with this guy. So this guy goes now down here instead of 1 plus S3 to the power of 3. So everything is tying up. So let's quickly do a little example, and we'll see it's not so bad. So they want us to value a 3-year bond, annual coupon rate 5%, and they've given us the forward curve for the 1-year rates. So what I did over here, this equation there, that's basically copied and pasted from the slide before. So we've done all the hard work from the slide before. So all we've got to do now is substitute in the rates from the table. So for example, for this term, we need the 1 year spot rate, which is there, the 1.75, and we need the 1 year rate 1 year from now, for example, that's 2.15. So just got to do those two. And then the same principle with this one, we need these three over there together, right? And that's going to give us, that denominator now is the same as 1 plus S3 to the power of 3. And that's it. That's all it is. Looks daunting, but a little bit of practice, we're going to be fine. If you have any questions, let me know. Otherwise, study hard, put those hours in, and we're going to be 100% all right. Hello, it's Tim here again. I hope you enjoyed the class and found it beneficial. We have some classes available for free on YouTube, but we have classes for the entire curriculum. The classes that are not on YouTube can be purchased from us. If you'd like to purchase the classes, please contact us for the pricing, and I've put our contact details over here. You can purchase all the classes or certain readings that you would like. When you purchase the classes, we provide you with the slides and our notes. I've assisted hundreds of candidates pass CFA exams, and I look forward to also helping you through the CFA program. I've put in 2 testimonials in the slide over here, and we also have a testimonials page on our website that you can review. I look forward to seeing you soon, and all the best.